Have you ever noticed how the continents seem to fit together like puzzle pieces? It's no coincidence. The Earth's surface is not static. It's in constant motion. This movement is called plate tectonics. But what drives these massive plates to shift and collide? The answer lies deep within our planet in a layer called the mantle. Imagine the Earth as a giant onion. It has layers. The outermost layer is the crust, which we live on. It's thin and brittle, like an eggshell. Below the crust lies the mantle, a thick layer of hot, mostly solid rock. The mantle is incredibly hot, reaching temperatures of over 3,700 degrees Celsius or 6,700 degrees Fahrenheit. Finally, at the Earth's core, we find a scorching hot ball of iron and nickel. The intense heat within the Earth's mantle isn't just sitting still, it's a dynamic and ever-changing environment. It's constantly moving, creating a slow but powerful churning motion called mantle convection. This process is crucial for the movement of tectonic plates on the Earth's surface. Think of a pot of boiling water. The heat from the stove causes the water to move in a circular pattern. The hot water rises, cools down, and then sinks back down, creating a circular flow. The mantle works similarly. This movement helps to transfer heat from the interior of the Earth to the surface. Hotter material near the Earth's core is less dense, so it rises towards the surface. This rising material can cause volcanic activity and the formation of new crust. As it rises, it cools and becomes denser. This cooling process is essential for the recycling of materials within the Earth. Eventually, this cooler, denser material sinks back down towards the core. This sinking action helps to drive the convection currents. This continuous cycle of rising and sinking creates giant convection currents within the mantle. These currents are a fundamental part of the Earth's geology, influencing everything from earthquakes to the creation of mountain ranges. These mantle convection currents are responsible for some of Earth's most impressive geological features. They drive the movement of tectonic plates, which in turn shape the surface of our planet in dramatic ways. For example, in the middle of the Atlantic Ocean, there's a giant underwater mountain range called the Mid-Atlantic Ridge. This ridge is a prime example of how dynamic and ever-changing our planet is. This ridge marks a divergent plate boundary, where two tectonic plates are moving apart. The process is slow, but relentless, with the plates drifting away from each other at a rate of a few centimeters per year. As the plates separate, magma from the mantle rises up to fill the gap, creating new crust and pushing the plates further apart. This continuous cycle of creation and movement is fundamental to the dynamic nature of Earth's surface. On the other hand, we have subduction zones. These are areas where tectonic plates collide and one plate is forced beneath another. Imagine the Pacific Ocean's Ring of Fire, a zone known for its frequent earthquakes and volcanic eruptions. This area is a hotbed of geological activity, constantly reshaping the landscape. This ring marks convergent plate boundaries where denser oceanic plates are forced beneath lighter continental plates. The immense pressure and friction at these boundaries lead to significant geological events. This process is called subduction. It's a powerful force that not only recycles the oceanic crust, but also triggers volcanic eruptions and earthquakes. As the oceanic plate sinks into the mantle, it melts, and the molten rock rises to the surface, causing volcanic activity. This cycle of destruction and creation is a testament to the ever-changing nature of our planet. The constant movement of Earth's tectonic plates driven by mantle convection currents is a fascinating and complex process. This movement is the main reason we experience natural phenomena such as earthquakes and volcanic eruptions. It also leads to the formation of majestic mountain ranges. When tectonic plates collide with immense force, the pressure can cause the Earth's crust to crack and shift dramatically, resulting in earthquakes. Volcanoes erupt when molten rock, or magma, rises to the surface due to the intense heat and pressure beneath the Earth's crust. This can happen at plate boundaries or volcanic hotspots where the Earth's crust is particularly thin or weak. When plates collide and push against each other with great force, they can cause the Earth's crust to buckle and fold. This process creates some of the world's most impressive mountain ranges. For example, the Himalayas were formed by the collision of the Indian and Eurasian plates, creating a breathtaking natural wonder. The mantle convection currents we've been discussing aren't a new phenomenon. They've been active for billions of years, constantly reshaping the Earth's surface. These currents are like giant recycling machines, pulling old crust down into the mantle at subduction zones and creating new crust at mid-ocean ridges. This continuous process ensures that the Earth's materials are constantly being recycled and renewed.